Let's begin today's lesson by reviewing how we solved factored form equations in yesterday's lesson. Anytime you see the word solve, remember your goal is to isolate the variable. Let's examine the equation carefully. We see that we have two factors. The first factor is 3m plus 11. The second factor is m plus 1, and the product of those two factors is 0. Now this is important. If the product of the factors is 0, then you can use the zero product property to solve the equation. The zero product property tells us that one of these two factors has to be a 0. So let's ask the question, what would n need to be for the first factor to equal 0? So we'll set that factor equal to 0 to find it. Now we know that the second factor might be the one that equals 0, so we need to figure out what n would need to be for that factor to be 0 as well. Now that I've written the two equations, I'm simply going to solve the equations for x. Eliminate the constant. Yields 3n equals negative 11. Isolate the variable by dividing both sides by 3. And our first solution is negative 11 thirds. Now the other solution could be contained in the factor n plus 1 equals 0. And we can clearly see here that in order for n plus 1 to equal 0, the n would need to be a negative 1. So our two solutions are negative 1 or negative 11 thirds. Now yesterday we referred to these two values as solutions. They have another name. They're called roots. So this polynomial equation has two roots. One is negative 11 thirds and the other is negative 1. Now yesterday we dealt exclusively with equations in factored form. Today, however, we're going to begin working with standard form equations. And we're going to learn how to rewrite them into factored form so that we can then solve them using the method we learned yesterday. To do this, we need to review how to factor out the GCF from a given expression. Let's take a look. The greatest common factor of these two terms, x squared plus 6x, is x. So I'm going to write that factor down. Now I need to divide the greatest common factor out of each term in my expression. 6x and x squared. X squared divided by x is x, and 6x divided by x is positive 6. Now notice what just happened. We went from a sum to two factors. One factor is x, and the other factor is x plus 6. From standard form on the left to factored form on the right. Let's factor one more expression. The greatest common factor of 3x squared and negative 15x has two factors. The greatest common factor of the 3 and the negative 15 is a positive 3. And the greatest common factor of x squared and x is x. So our GCF has two factors in it, 3 and x. We need to now divide each of the terms by our GCF. Dividing 3x squared by 3x yields x, and negative 15x divided by a positive 3x yields a negative 5. Once again, notice what just occurred. We've gone from standard form on the left to factored form on the right. And factored form consists of three factors, in this case the 3, the x, and the x minus 5. So now we're ready to start solving equations in standard form. The first equation in standard form is 3x squared minus 15x equals 0. And this is in standard form because one side already equals 0. So we're ready to rewrite the equation into factored form. We do this by factoring. So we take a look at the two terms, and we recall from our previous example that the GCF of those two terms was 3x. And when we divide each of the terms by our GCF, we get x minus 5. And the product of those three factors is 0. And because the product of those three factors is 0, we can use the zero product property to solve the equation. So let's take a look. The first factor is 3. But 3 is constant, so 3 can't equal 0. So the next x factor is the x. Now the x is a variable, so it could equal 0. So our first solution is x equals 0. Now the next factor that it might equal 0 is x minus 5. So we need to figure out what x would be for x minus 5 to equal 0. We see that x would need to be a positive 5. Let's check to see if our solutions are correct. We take the original equation and we replace each variable with a set of parentheses. We're going to plug in our suggested roots. Our first solution is 0. Well, 0 squared is 0, and 3 times 0 is 0, so this product is 0. Negative 15 times 0 is, well, 0. And 0 minus 0 we know equals 0. So our first root is correct. Let's check our next one. 3 times 5 squared minus 15 times 5. We want that difference to be 0. Well, we follow the order of operations and we get 25 times 3. And 3/4 is 75. We need to subtract 15 times 5, and that product is 75. We see that 75 minus 75 does in fact equal 0. So our second root is also correct. Now our next equation is not written in standard form. So our first move will be to rewrite the equation into standard form. To do that, we need to make one side equal 0. So I'm going to make the right side equal 0 by subtracting 6x from both sides. This yields 2x squared minus 6x equals 0. Now that the equation is in standard form, I can begin to rewrite it into factored form by factoring out the GCF from the left side. Now the GCF of 2 and 6 is 2, and the GCF of x squared and x is x. Now I need to divide each of those terms by my GCF. 2x squared divided by 2x is x, and negative 6x divided by 2x is minus 3. And the product of those factors is 0. And because the product of my factored form equation is 0, that's going to allow me to use the zero product property again. So let's take a look at our factors. Which factor could equal 0? Well, the first factor is 2. And 2 is constant, so it couldn't equal 0. The next factor is x. Now x is a variable, so x could equal 0. So there's our first root. X equals 0. Now the next factor that might equal 0 is x minus 3. So we need to figure out what x is for that factor to be 0. And from this statement, we can see that x would need to be a positive 3. Now let's check our work to see if we've got the correct solutions. 2x squared equals 6 times x. And our first solution is 0. Well, 0 squared is 0, and 0 times 2 is also 0, and 6 times 0 is 0. So that was easy. Our first solution checks. Let's check the second solution. 2 times 3 squared, we want that to equal 6 times 3. 3 squared is 9. 2 times 9 is 18. We want that product to equal the product of 6 and 3, which is 18. So we can see that 18 does in fact equal 18. So our second root is also correct. Let's try one more. Now this equation is not in standard form. So my first move will be to rewrite the equation into standard form. To do this, I'm going to add 3m to both sides. So my left side equals 0, and the right side equals 9m squared plus 3m. Now this equation is in standard form because one of the sides, in this case the left, equals 0. So my next move will be to rewrite the equation into factored form by factoring. Now the GCF of the right side is 3 and m. Now I need to divide each of those terms by the GCF. 9 divided by 3 is 3. M squared divided by m is m. 3m divided by 3m is a positive 1. I know that the product of those three factors is 0. And because of this, I can use the zero product property to solve the equation. So let's go through the factors and figure out which ones might equal 0. Well, the first factor is a constant, 3, it can equal 0. The next factor is an m. Now that's a possibility because it's a variable, so m could be 0. So there's our first solution. The next factor that might equal 0 is 3m plus 1. So let's figure out what m needs to be for that third factor to equal 0. We do that by setting the factor equal to 0. Eliminate the constant. Isolate the variable. And our second solution is a negative 1/3. Final step will be to check. So on your notes, I would like you to run the check step. Make sure you bring your notes to class so we can review your check step together. We'll also review your understanding of this concept. And during the class tomorrow, we're going to be taking equations in standard form, rewriting them into factored form, so we can solve them using the procedure that we talked about today.